In this video, we're going to focus on the topic of relativity. Not Einstein's relativity, of course, that would require a much higher understanding of physics. In this video, we're going to focus on a more simpler version of relativity, which some might call Galilean relativity. Suppose that you have two people, one called A and one called B. Now, relativity says that in our universe, we don't have just a single big magical clock that's ticking the same for everyone and everything. Instead, we have individual clocks, which leads to a bunch of different paradoxical things, but again, that requires a higher level of understanding, focused on Einstein's relativity. Let's say that we have an object of x with a different distance from A and B. We know that B is moving with a constant velocity to the right. This leads to A and B creating different frames of references, which we will call SA and SB. Let's draw a coordinate system for the frame of reference of A. This is our object, x, and we can define the distance from A to x with a radius vector, which we will call RA. And SB, on the other hand, will be moving relative to SA with a factor such as this, V times T, because in every different frame, B will be moving a little more bit to the right by this factor right here. And it will be shifting more and more to the right relative to A as more time progresses, which will result in a different distance vector to x, which we will call RB. Now from this, what we can gather is this. We know that RB can be defined by the difference between RA and VT. How about we divide all of this by T? Well, this is what we'll get. We will get VAB, which I'll explain in a second, VA minus VB. Now this is our relative speed equation. But what does it mean? It means that the velocity of A relative to B is equal to the velocity of A divided by the velocity of B. And this relative perspectives is usually defined to the ground, which means that the velocity of A relative to the ground, which is taken as stable generally, and the velocity of B relative to the ground. So to understand it more intuitively, let's say, for example, we have a person standing stable on the ground, which we will call Joe, and another person going with a weird looking vehicle with a stable velocity, which we will name Mike, with a velocity of Vm. Now, in the perspective of Joe, Mike is moving to the right with a velocity of Vm. But in the perspective of Mike, Joe is moving to the left with the same speed of Vm. And you can see this from the equation. The relative speed of Mike relative to Joe is the difference of Mike's speed minus Joe's speed. And since Joe is stable, this is just Vm. But the relative speed of Joe in the perspective of Mike is Joe's speed minus Mike's speed. And since Joe's speed is 0, it means that this is just Vm with a negative sign on the front, which means left and not right. And that's basically the whole concept of Galilean relativity.